Okay, let's find the antiderivative of a rational function. This is an indefinite integral, meaning we don't have bounds for our integration. We're going to need to use the chain rule to get through this one. All right, so as we get going on this, we're going to pick out u is going to be the denominator. And then we take the derivative of both sides of this equation we've set up. So we get 1 du equals, using the power rule, 2x dx. I left off the plus 0, the derivative of our constant. All right, next up, what we want to do is we want to be able to replace in and get rid of that x from the numerator, because the entire denominator will be u. But for the numerator, what we want to do is we're going to replace and get rid of that x dx. To do so, we're going to have to rearrange our green equation at the bottom. We want it just to be x dx, so we want to move the 2 to the other side. We can either think of that as dividing by 2 or multiplying by 1/2 to get us x dx on one side by itself. Now you may be saying that 9 in the original function, that's a problem. And it's only a little bit of a problem. What we can do is we can move that 9 out in front, leaving us with 1x over x squared plus 1 dx. Next, let's do our substituting in. So what we want to do is we'll bring the 9 along, the integral symbol, and then we're replacing the 1x dx. That's going to get replaced with 1/2 du. So 1/2 du. We're going to leave that 1 up in the numerator, and then our entire denominator can be replaced with u. A little bit of just rewriting this. I'm going to move the 1/2 out in front. So 9 times 1/2 is 9/2. And then we have the integral of 1 over u du remaining here. Okay, you may be thinking you can say u to the negative first power, but using the power rule is not going to work in this situation because -1 plus 1 is going to be 0 for our exponent, and we don't want that to happen. Okay, so this works out to be the special case where it's going to work out to be the natural log, that should be an absolute value of u. And then we also include a plus c at the end, meaning we could be adding a constant onto this as well. So we're almost done with this, but we're still in terms of u. We need to get back to x's. So in this situation, we'll have 9/2 natural log, and then we want to replace back in where u is currently. You're going to use your let statement and go back to x squared plus 1 gets filled in there inside the absolute value where the u was. All right, I hope this helps out as we're learning about the u substitution and working some indefinite integrals. Good luck.